From manufacturing to healthcare and everywhere in between, 3D printing has revolutionized production forever. The ability to build products layer by layer with little to no waste is set to transform the world in many ways. Initially, only plastic was practical in 3D printing, but other materials like metals and even living cells are now possible. However, it is the ability to 3D print metals that can be seen as a quantum leap in fields like precision engineering. And this is where one company, Meltio, is setting a new standard. Founded to make individual metal parts for sale, the company has become one of the leading lights in the metal 3D printing ecosystem. The company realized the limitations of existing 3D printing technology and decided to find a new way to design 3D printing machines capable of producing the metal parts it truly desired to make. From this founding philosophy, Meltio's Directed Energy Deposition, or DED, 3D printers were born. Their range of metal 3D printing machines is next generation, working effectively like highly precise laser welders. So, if a product or material can be welded, it can be 3D printed. Meltio's 3D printing heads can produce unparalleled precision and control without sacrificing the quality of the final product. They produce a constant flow of molten metal in layers, allowing these machines to produce any metal structure engineers can put their minds to. Meltio have taken their 3D printing machines one step further with the introduction of the M600. The M600 uses blue laser diodes that greatly improve energy absorption and printing efficiency across the metal material spectrum. The energy consumption per component is reduced significantly, resulting in a greener and more cost-efficient process, as Lucas Hopper, Meltio's director of R&D, explains.
So the new technology really takes all of these components, we're integrating all of the laser system into the printhead. We're changing the wavelength of the laser system from something that is near infrared in the current technology to blue lasers. So this gives you much better absorption across a broad range of metals and enable processable with the laser technology. So talking of aluminum and copper alloys, which are very reflective to near infrared light. And all of these materials, they have very high absorption in the blue wavelength. So that's, the enabler of this new technology.
With a workspace of 300 by 400 by 600 millimeters, the Meltio M600 allows printing of large parts or a batch of small parts simultaneously in a row. It is designed for reliability and quality, with inbuilt process monitoring through a large array of integrated sensors and a vision system. It also has the possibility to use up to 4 materials sequentially on the open material platform Meltio call QuadWire. Amplifier capabilities with additive manufacturing form innovative hybrid solutions, opening up even more possibilities for its clients. They can work with various metals. Not only that, but the parts produced with the Meltio printheads are of incredibly high quality. Meltio are also pushing new capabilities in 3D printing. It is now possible to build entire houses with specially formulated concrete mixtures using a concrete 3D printing nozzle. This requires advanced equipment, and the last interface between the machine and the final product is the deposition nozzle. Concrete printers usually employ simple nozzles prone to premature failure due to wear. Working with Cementos La Cruz, Meltio have developed a stainless steel solution that can be manufactured in a few hours, guaranteeing tailored, controlled performance over a much longer operational lifetime. But these are only the first steps in Meltio's plans for the future. The next phase is to build more controls and monitoring apparatus to enable Meltio to certify its manufactured parts. But with the basics in place, this will only be a matter of time. So if you want to leap into the future of metal part production, you needn't look any further than Meltio's impressive range of metal 3D printing solutions.